This video will cover the second page of notes on the topic of exponential and logarithmic equations. In the previous video, we solved exponential equations, in which sometimes we had to use logs. In this video, we will be solving logarithmic equations, equations that already contain logs. Again, there are two types, and here's type number 1. In this case, we have log base 3 of x plus 6 minus log base 3 of x plus 2, and that's equal to the log base 3 of x. We want to use one of our properties of logs in which we can combine these two expressions of log. So one of the things I want to remind you of is that we know that if we have the log of some base of some number and we're adding another log that has the same base but maybe of a different number, then we can write that as one log of the same base, and we multiply those two unknown numbers. And we also saw this was also true if we were subtracting. So if we had a subtraction here, then we would have dividing our two expressions. So we would have the log of base b of m minus the log of base b of n would equal to the log of base b of m over n. So that's the one we have. We have a minus sign between our two logs. So we're going to combine those two logs to become the log of base 3 of the quotient x plus 6 divided by x plus 2. Notice this only works if you have the same base. Now that you have that, we have on the left side one log expression, the log of base 3 of the quotient x plus 6 divided by x plus 2, and on the right we still have log of base 3 of x. This is very similar to having the same base on both sides when we were solving exponential equations. If you have the log on both sides of the equal sign, only one log on each side, and they have the same base, we can actually ignore those and just look at the quantity of x plus 6 divided by x plus 2 equaling to x. This was equivalent of when we had the same base and then we said that the exponents were equal. So we're doing the same thing here. Now our job is to solve this rational equation, and again we know how to do that. First we're going to look at our domain restrictions. In other words, we know x cannot equal to -2 because that would cause our denominator to be 0 and our whole expression to be undefined. Once I've done that, I'm going to multiply both sides by x plus 2 since I want to get rid of fractions. So on the left side, I'm going to multiply x plus 2 times our fraction of x plus 6 divided by x plus 2. We can see that those factors will go away and I just end up with x plus 6. I multiplied the left times x plus 2, so I'm going to multiply the right times x plus 2. Notice nothing cancels there, but I can use the distributive property to find x squared plus 2x. So now I'm left with solving the equation of x plus 6 is equal to x squared plus 2x. From here, since this is quadratic, remember that when we're solving anything that looks quadratic, we want to set that equal to 0 so that I can factor and continue solving. So that's what we're doing here. Because I already have x squared is positive, I'm going to subtract x from the left side and the right. I'm going to subtract 6 from the left side and the right, and that will leave me 0 on the left side. I'll have x squared plus x minus 6. And again, it doesn't matter which side I put the equal to 0 part, so I'm going to do that on both sides, or erase the one on the left and just have x squared plus x minus 6 is equal to 0. I'm going to factor. That gives me x plus 3 times x minus 2, and those are equal to 0, so I let each of the factors equal to 0, and that's how I can solve that x can either equal to -3 or positive 2. Now remember, we said that we should always check these answers to make sure that works. So we notice that our answer is acceptable since neither one of these are equal to negative 2. We're still going to check. The main reason why we're going to check is because our log graphs have a restriction of our domain being from 0 to infinity, not including the 0. So here we are checking. Notice I am checking to see what happens when x is equal to negative 3. When I do that, I'm sticking it into my original equation. My original equation said that we had the log of base 3 of x plus 6 minus the log of base 3 of x plus 2, and we claim that to equal to the log of base 3 of x. So I just wanted to rewrite it so that we can see that I am doing negative 3 into here. Negative 3 plus 6 is positive 3. That's how I get log base 3 of 3. Over here I have a negative 3 plus 2. That gives me a negative 1. So now I have log of base 3 of negative 1. And then I have log of base 3 of negative 3. But what we find out is that we cannot have log of a negative number because we said our domain has to be some positive number. So therefore, x cannot equal to negative 3. So let's check to see what happens if we plug in x is equal to 2. So I'm going to plug in 2 here. So now I have log of base 3 of 2 plus 6, which is 8. So I have the log of base 3 of 8 minus, plugging in 2 here, I'll have the log of base 3 of 4, and I claim that to equal to the log of base 3 of 2. So now we just need to check to see if this is true. We can check this by either going into our calculator and plugging it in and see if it's true, but the other thing we can do is still use our properties. We know that we would divide these two because they're being subtracted. So I would end up with the log of base 3 of 8 over 4. That's the same thing as log of base 3 of 2. So it's working if we use our log properties. So we have found that the only solution we have to this is that x can equal to a positive 2. The second type of problem that we might encounter that involves logs is going to be where we have logs in the equation only on one side and actually equal to a constant on the other. Again, we're going to notice that our logs will have the same base. That's good to know. We're going to use a property of logs, the one that says that if you have the log of the base of m plus the log of the base of n, so I'm going to combine this again to become one log. We're going to see that this is going to be the log of base 8, and I'm going to get my 3x plus 2 times my x minus 1. Since we don't have the log to both sides, we have to either rewrite the 1 as a log of base 8 of 8, or we can rewrite our log problem as an exponential problem. In other words, we know this base of 8 to this exponent of 1 must equal to the argument inside. So that's how I have 8 to the 1 power is equal to 3x plus 2 times x minus 1. Now we need to rewrite it so that it looks something familiar to you. We're going to do FOIL because we're multiplying 3x plus 2 times x minus 1. That's how we get 3x squared minus x minus 2, and that's equal to 8. Then because it's quadratic, we're going to set it equal to 0, so I'm going to subtract 8 to both sides. And that's how we have 3x squared minus x minus 10 is equal to 0. We're going to factor, set each of those factors equal to 0. That's how we find x is equal to negative 5 over 3, and we find x is equal to 2. Now we need to check. If we're going to check x is equal to a negative 5/3, Notice that if we come up to our original equation, if I put it into the log of base 8 of x minus 1, that's going to be log of base 8 of negative 5/3 minus 1. It's going to be a negative number. And we know that our domain says you have to be greater than 0. So that's how I know this one will not work. X cannot equal to a negative 5/3. Let's see what happens if we decide that x is equal to a positive 2. We can see here that we're going to have 6 plus 2 is 8, so we would end up with log of base 8 of 8. Over here we would end up with log of base 8 of 1 plus log of base 8 of 1, and that should equal to 1, not 0. We know from our properties that log base 8 of 8 is equal to 1. Log base 8 of 1 is equal to 0. Let me remind you why. Because if we have the log of base 8 of 8 is equal to some unknown, then we would write down 8 to my exponent is equal to 8. The only way that works is that that exponent is equal to 1. For the other one, I would have log of base 8 of 1 is equal to something. That means 8 to that exponent must equal to 1, and the only way that happens if our exponent is equal to 0. So that's how I know that this is equal to 1 and log base 8 of 1 is equal to 0. When I add them, they're going to equal to 1, which that's what our original problem said it would equal to. So it actually works. So then we find that our solution is going to be x is equal to 2. And that concludes this video.